Welcome to this eLearn Security video training lesson on iOS runtime manipulation with Cycript. In this video we are going to see how to use Cycript to perform some runtime analysis against applications installed on the device. We will first see how to interact with the Cycript shell, edit application configurations and properties, as well as how to use Cycript to change the app behavior or bypass security checks. Let's shed some light on Cycript. Cycript is a JavaScript interpreter which also understands Objective-C syntax. Since it can hook into running processes, it is a great tool to use in the runtime analysis phase. As we will see in this video, we can attach Cycript to a process running on our device and use its interactive shell to control the app. Before we start using it, let's see how to install Cycript on the device. To do this, let's open Cydia from our device and move to the Search tab. Once there, search for the string Cycript and click on the first result. It will open the Cycript package. Now let's click Install and wait until it finishes. So here it is. Cycript has been installed on the device. Note that we can also install Cycript by downloading the deb package from the website www.cycript.org/debs. We just need to download the latest version for our OS version and upload the package on our device. Once the file is stored on the device, we can just run dpkg-i followed by the name of the file just downloaded. This will install Cycript on our device and we'll be able to use Cycript from an SSH shell. So let's start an SSH shell to the device. We're going to use iTunnel to establish the connection via the cable. Now that we have our shell, let's see how to use Cycript. For our test, we will first use the Springboard application. After that, we will target custom applications in order to see how to bypass security checks or force the application to perform specific operations. The first step is to hook Cycript into a running application. We can do this in two different ways. We can use the process ID or the name of the application. Let's run the ps command to find the process ID of the Springboard application. Here we see the PID. Let's now attach Cycript to this process with the following command: Cycript -p followed by the PID. As we can see, we've successfully attached Cycript. As said before, we can also use the full name of the application. Let's quit this Cycript session by pressing Ctrl-D and let's attach to Springboard again. This time, let's use the process name so our command will look like the following: Cycript -p Springboard. Once again, we are attached to the Springboard process. Cycript is a JavaScript interpreter which also understands Objective-C syntax. To demonstrate this, let's try to run some commands. Let's declare a variable using JavaScript syntax. var x = 5 . As we can see, the interpreter knows we are writing JavaScript code and highlights its keywords. We can print the variable value just by writing its name. Here it returns 5. Let's now create a JavaScript function that returns the double of the variable x. So let's write the function, the name of the function, double it, and press return for a new line. As you can see, the hashtag disappears, meaning that we are still writing the code related to the previous line. So we can continue with our function implementation. We want to return the double of the variable x, so we can write something like return x times 2 semicolon. As we can see, we are still writing code for the function as indicated, so we need to close the curly bracket. As soon as we press return, we can see that the hashtag disappears, meaning we are done with the function. So now that we have our variable and we have our function defined, let's call the function, double it with the following command. Double it, open parentheses, close parentheses. As we can see, it returns the double of the variable x. If we change x from 5 to 4, and then we call the function again, the result changes. So now that we know that the JavaScript interpreter works, let's see if we can combine JavaScript syntax with Objective-C syntax. Let's suppose we want to declare a string in Objective-C and assign its value to a JavaScript variable. We can do it by allocating and initializing the string with the following command. var myString equal bracket bracket NSString ALLOC close bracket init with string colon at quote ELS end quote close bracket semicolon. If we print myString, it returns the string ELS. Now we can use the variable myString as an Objective-C string. Now we can call all the methods implemented for the string. For example, let's print the class for coder, which of course returns NSString, or uppercase string, which returns the string in uppercase. This doesn't work for just strings. It could be used for almost every Objective-C object. For example, we could create an Objective-C array and assign it to a JavaScript variable. This is very similar to the previous command. Now we can edit this array by using Objective-C methods addObjects. Let's add a few elements with the addObject method. Let's try to add a new integer element with the previous command. If we print the array, we can see that we have the two elements. We can also use JavaScript to do this. For example, we can use push to add an object into the array. So as we can see, we can combine JavaScript with Objective-C syntax in a very easy way. As we'll see later on in this video, this feature will come in handy. Now that we have a brief overview of how Cycript works, let's start interacting with the attached application. We know that we can use Objective-C syntax, so let's run the command to get the singleton application instance. To do this, we can use the UI application object with this command. As we can see, we have the instance object of the application. Since it is one of the most used commands, Cycript implements a shortcut for this command, which is UIApp. It returns the same result. From the app instance, we can now navigate its properties, methods, objects, and so on. Now let's try to navigate through its Windows property. To do this, we can simply write uiapp.windows, which returns an array that contains all the UI window objects associated with the app. In other words, it returns all the visible and hidden windows. Of course, since it is an array, we can access each element of the array by adding at the end of the command the index we want to access. For example, Let's access only the first element by adding 0 at the end of the previous command. Here we can see we have the first element. In this first part of the video, we want to edit some graphics properties of the icons displayed on the screen. Let's navigate until we reach the icon list view subview, which manages the icons in the springboard window. To do this, let's append subviews to the previous commands. Once again, let's select the first element to access the root view. Let's now recursively access its subview till we find icon list view. Here, let's select the element SB icon content view, which is the second element. Then again, let's select the second element, which is SB icon scroll view. After a few steps, we can see the subviews named icon list view. Each element of this array corresponds to one screen of the device. In our device, we have 3 screens where the application icons are displayed, plus 1 screen for the search. If we open VNC, we can see that at the beginning we have the search view. Then if we scroll right, we have the first view containing the application's icons. Then again, this is the second view. And at the end, the third view. To verify that each one of these elements is one of these views, let's append icons to the first element. As we can see, the first element of this new array is the first icon on the screen. We have mobile SMS on the left and the messages icon on the device. The same is true for mobile cow and mobile show. Let's now change the index of the array and see if it prints out the icons in the second view. As we can see, we have Stocks, a folder icon, Evernote, and others, which are the icons in the second view of our phone. So now that we have reached the icons on the screen, what can we do? As we said previously, Cycript can be used to change properties as well as call methods, create objects, and more. So let's access the element corresponding to the messages icon and list all of its properties. Let's select the first view and then add subview 0. Now let's add a dot at the end of the previous command and press tab 2 times to print out all the properties of the element. As we can see, we have a very long list of methods and properties that we can use. At the beginning, there is a property named alpha. This indicates the alpha value of the icon on the screen, meaning that if it is set to 1, the icon is completely visible, while if it is set to 0, it is completely transparent. So let's access this property and print its value by adding .alpha at the end of the command. As we supposed, its value is 1. Indeed, the app icon is visible in the device. Let's then try to change it to 0.50. As we can see from the VNC viewer, the transparency of the messages icon has changed. So let's set it back to 1 and continue. There are many other properties that we can access. For example, we can print the name of the icon by adding display name at the end of the icon object. Let's first print again all the icons of the second view, then access the element for the stocks application, and then add the display name property. As we can see, it prints out the name of the icon. As you can imagine, depending on the object we are trying to access, we can set different properties. For example, in the second view, we can see that a second icon is a folder, so it is slightly different from the others. To demonstrate, let's print the folder property of the first icon of this view. As we can see, it returns null because it's not a folder. So let's change the previous command in order to point to the second view. Let's change the value of the subview from 0 to 1. Since it's a folder, it returns the object of the folder. From here, we can, of course, continue to navigate this object. We can print out all the objects contained in it by reading the property contained node identifiers. Here we can see the items contained in this folder. If we open the folder on the phone, we can see each element of the view. We have the compass icon, the calculator, and voice memos. So again, depending on the object we are trying to access, different properties can be used. While with the previous commands we have read and set properties, let's now see how we can call implemented methods for each object. Let's see how we can change the badge number that appears over an icon, like the badge displayed over the icon's App Store and settings. To do this, we'll have to call the method setBadge. In Objective-C, we can call methods with this syntax. So in our case, the object is the one used in the previous command. Now we can see that we are using the object of the message icon. Let's tweak our input by assigning the object to a variable. Let's call it iconMSG and assign the message icon object. Now every time we want to use this object, we can simply write iconMSG. Before calling the method setBadge, let's print out all the methods available for this object. We can do this by writing iconMSG and then press Tab 2 times. As we can see, there are lots of methods that are going to be printed, so let's limit the results by listing only the methods that start with set. Now we have just a few methods, and as we can see, there is setBadge. So let's continue writing our command and set the badge number to 444. If everything works fine, once we run this command, the icon should change. And indeed, we can see now the icon has the number set to 444. So let's set the badge number back to 0 and try to launch one of the applications listed in the screen directly from Cycript. Let's create another variable named iconPhoto and set its value to the icon photo on the screen. Note that the first element of the array is at the position 0, so the photos icon is at the position 2. Let's print out the display name to be sure we're on the correct icon object. Here it is. Let's use a command similar to the setBadge, but this time let's use the method launch, iconPhotos launch. As we can see, when we hit return, the application starts on the device. As we have seen, we are able to interact with the application objects, but it's important to know that we can also create objects and execute functions that are not related to the application itself. For example, without interacting with any of the objects we've seen up till now, let's see how we can pop up an alert message. First, we need to allocate and initialize a UI alert view object with the following code. Then we could set the title and the message property with these two commands. Alert title equal runtime analysis and alert.message equal Cycript alert. Now let's call the function addButtonWithTitle in order to add a button to the alert. Alert addButtonWithTitle at and dismiss. The method works. It returns the index of the button. Note that the command also works if we add the semicolon at the end of the command. If we add it and then hit return, we can see that it now returns 1. Now that everything is set, we need to display the alert. To do this, we can simply call the method show. So let's write alert, which is the object, and then the method show. As we can see on the device, the alert appears. Now that we have seen how to access objects, edit their properties, create and call methods, we can try something more interesting. What we're going to do is try to bypass the passcode screen that appears when we unlock the device. First, let's prove that if we lock and unlock the device, the passcode screen appears. We can also verify this by issuing the following command. SB device lock controller, shared controller, space is password protected. As we can see, it returns 1, meaning that the passcode screen is enabled. In order to bypass the screen, instead of changing its value, we are going to replace the implementation of the method is password protected. The purpose of this is to force the method to always return 0. To do this, we can use the method messages, which contains an associative array of messages in the class. In other words, it prints out all the methods associated to a specific class or object. SB device lock controller.messages. We can see all the methods, and in particular, the method is password protected at the beginning. Cycript allows us to replace method implementations using the following syntax. By adding a function, open close parentheses, squiggly bracket, return 0, semicolon, close squiggly bracket. Let's verify that the method has been replaced by calling it. As we can see, it now returns 0. Now that we've replaced the function, we need to call a method that tries to unlock the device. We can do this by issuing the following command. Let's now try to lock and unlock the phone from VNC. As we can see, the passcode screen has disappeared, so we have successfully bypassed the passcode screen. Let's try to set the function back to 1 and see if the lock appears again. As we can see, by replacing 0 to 1, the screen lock appears. So every time we want to bypass this, we just need to change the method implementation and then call the attempt device to unlock method. It works again. In this video, we have seen a very powerful tool called Cycript. We have seen how it's possible to use both JavaScript and Objective-C syntaxes, even when combined. We have also seen how to access classes and objects in order to change applications' properties or call specific methods. At the end, we have also seen how it's possible to replace existing methods in order to bypass security checks, such as the passcode screen that appears when we unlock the device. We advise you to try Cycript on existing applications as well as on custom apps in order to understand how to control and manage the app. Thanks for joining us.